One is the immediate view maintenance, and the other is deferred. And in deferred, it comes in three different flavors. One is the lazy approach, second is the periodic, which is also called as snapshot approach, and the third is event based. So, let me so immediate and deferred. So what this means is that immediate means, say, okay, let me so I have a metallized view, which is nothing but a join of the tables R and S, right? Okay, so R and S is joined, and the result is materialized in the form of a materialized view. Now, immediate means, so as and when there is a change in either an R or an S, I'm going to update the materialized view immediately, right? So that is the immediate one. So it is actually part of the update query. So whatever update query I'm issuing on R, say I'm saying insert a tuple in R, right? So this materialized view is updated, right, as part of this query itself, right? So what happens is that the query itself, which is updating, is delayed. Okay. Now the second is deferred. So I do the updates to R or S or both, but I don't worry immediately about updating the materialized view. And this we can do in three different ways, so I'll be discussing that. So the problem statement is like this, that you have a materialized view, and it is based on some base tables, or the underlying base tables, which is R and S in this case. And if R or S or both change, how do we change the materialized view? Okay. So a materialized view is said to be refreshed when it is made consistent with changes to its underlying tables. Okay. To its underlying tables. So often referred to as view maintenance. So there are two basic issues: how do we refresh, and when do we refresh? So we'll try to answer all these questions in the coming slides. So the task of keeping a materialized view up to date with the underlying tables is known as materialized view maintenance, or simply view maintenance. Materialized views can be maintained by recomputation on every update. So one of the things that I can do is that I have this materialized view, which is R join S. So R changes, so I drop this view and create the new materialized view. But if suppose R and S are very large relations, and I'm just inserting one tuple in R, and for that I am dropping the view and doing this join again, so that would not be a very good idea, right? So we don't do that. So a better option is to use incremental view maintenance, right? So what happens in incremental view maintenance is that changes to database relations are used to compute changes to materialized views, which is then updated at a later point of time. Okay, so view maintenance can be done by there are different strategies for doing this. Manually defining triggers on insert, delete, and update of each relation in the view definition. Manually written code to update the view whenever database relations are updated, or supportly directly by databases, right? So there are direct support, so you don't have to. So once you define a materialized view, so they would have some default strategies to maintain the materialized views as and when the underlying tables are changed, right? So it is actually done in two steps. One is propagate, so compute changes to the view when data changes, and then you apply those changes, right? So as I told you, we are talking about two different policies for maintenance. So it controls when we do. So this is about how, and this is about when. So there are two options, as I told you earlier also, immediate and deferred. So it is part of the transaction that modifies the underlying base tables. The positive point of this is that materialized view is always consistent with the underlying tables, and the negative point is that updates are slowed. So you don't want updates to be slowed, so you have to decide. And the second one is deferred, so it is done at a later time. in a separate transaction. So the negative point is that the view may become inconsistent for some time, till the time you actually carry out the updates on the metalized views, or you refresh the metalized views. Plus point is that can scale to maintain many views without slowing updates. So if I have multiple views, so I can control the way, or I'll have a very scalable kind of a solution when I have multiple views, and at the same time I'm not slowing down my update queries, right? So this is a positive point of the deferred strategy for view maintenance. And at the same time, as I told you earlier also, in a data warehouse environment, we are not too particular about consistency of data, so that helps our cause. Now, deferred maintenance. So there is nothing much to discuss in the immediate one, because that you understand. So that is part of the query that is updating the underlying tables, and the view is metallized. A view is updated accordingly as part of the transaction. So three flavors. So it comes in three flavors: lazy, periodic, and event based. So lazy is like this. So I have R and S which I have joined. Okay, I'll write it like this. So this is a metallized view. R join S. Okay. So now changes are being made to R, changes are being made to S, right? So this is a deferred one. So I'm not changing this at all. So this metallized view is as it is. So now to explain this concept of lazy approach, so suppose, so this metallized view will not do anything, right? It will not worry about whether R or S or both have changed or not. Now suppose there is a query that comes to the metallized view. Now somebody is trying to query the metallized view. Now the metallized view would wake up, right, and go and check with R and go and check with S whether any updates have been carried out. If there have been updates that are there, so it will try to update itself according to those changes, right? This is how it works. So what happens is, this query has to wait till this metallized view goes and checks the underlying tables, right? So this delays the query. And if there are changes, those changes have to be propagated to the metallized view, right? So this is called as the lazy approach. So now you understand why it is called lazy, because I'll not do, the metallized view will not do anything even when R and S are changing, right? So it will wake up only when there is a query. So this query will wake up this metallized view and say that I want consistent data, go and check with your underlying tables whether any updates have been carried out or not, and then this query would run after that. So this is the lazy approach. Periodic, so it is refresh periodically. So irrespective of whether there is a query on the metallized view or not, every hour I would go and check the underlying tables and refresh. So and so queries possibly answered using outdated versions of view tuples, widely used especially for asynchronous replication in distributed databases and for warehouse applications, right? So this is useful in some situations. And then third is event based. So refresh after a fixed number of updates to the underlying table. So here I'm saying that if there is just one update to R and one update to S, I'll not worry. So I can say that, so suppose there are three underlying tables, three tables which are used to define a metallized view. I can put a threshold saying that if there are more than 5 updates on each table, then only I would update, okay, the metallized view. Or I can say if the total number of updates are exceeding 10, then only I'll update the metallized view. So like this you can define events which would trigger the update process of the metallized view. So all these three deferred strategies have their own pluses and minuses, right? So so let me try to summarize this in the Next slide. So before I come to this, let me just summarize. So lazy, and then periodic, and then the third is event based. So lazy, current currency of data is always maintained. Periodic, not necessarily. Event based, not necessary. Okay, are you getting this? Then response time is it goes up, which is not a good thing, because your query has to wait till the materialized view is going and checking checking for updates. Periodic, response times would not suffer, so response times would actually go down because we are using materialized views. And event based, so the delay in query, actually not right, it's not good to write response times, delay in query, delay. So delay would be there, so I'll just replace this by plus this yes or no. Delay, yes. Periodic, so the probability of delay would be very small, only when it will happen only when the updates are actually being carried out, so I can say no. And event based also it is low, so there will be no delay in the queries, right? But you may not get the response time, you may not get the current data in periodic and snapshot in event based. So this is what are the three strategies, so you can use any of them based on your requirements. So I've discussed the pros and cons of all this, right? So let me now talk about, so this would be discussed in the next lecture. So recomputing the view when an underlying table is modified. So this is a very straightforward approach, but it is very expensive. So not feasible to do so for all changes made. So what we do is we try to use what are called as incremental algorithms for refreshing a view, right? We use that. So what are incremental algorithms basically? So cost of refresh. So suppose I inserted one tuple or 10 tuples in a relation, right, R. So the cost of updating the materialized view based on R, right, should be proportional to the size of the update or to the extent of the change, right? So this concept I'll be discussing in the next lecture, that is incremental algorithms for view maintenance, wherein I'll be talking about the major operations in relational algebra. So it would be good if you are familiar with relational algebra in general. So I'll be talking about joins and projections, I'll be talking about selections, I'll also be talking about aggregate operators. So which are the three main operators that are used or used in data warehousing, right? Aggregation and joins basically, and also of course selections and projections. So with this I wind up today's lecture, and the next lecture would be on incremental algorithms for view maintenance. Thank you.